So for example, if I put 2412, so this is an airfoil that is used mainly in different types of airplanes. So here, these are the number of panels. So for example, I want to have 100 points that create this airfoil. So now if I click on OK, so this airfoil will be added automatically here. I said that you can change the color here. And you can change the width of the line. Click on OK. So this is one airfoil. So now I want to add two airfoils here and go to the analysis. We want to run the analysis, and then we want to make an airplane out of this airfoil. This is something that I want to show you. So then after that, let's say for the horizontal tail of the airplane, we usually have different types of airfoil than the airfoil that we are using for the wing. So here, or for the vertical tail, I am going to add NACA 0006. It means that I have an airfoil here. If I make it red color, I have an airfoil here with a thickness of the 6 and with a camber of 0, right?
Right.
The first digit, it shows the camber. The second one times 10, it shows the percentage where you have this max camber, and 12 shows you the thickness. So this is a 12, and this is 6, right? So it means the thickness of this, the maximum thickness is 6%. So if this is 0.06 centimeter, this is going to be 1 centimeter because this is a normalized chord length. So you're adding your geometry here, and then we can go to the file and we can go to XFoil direct analysis. So here's the place that we run analysis. So if I select this, I have these two airfoil that I have added here, and then I can select them and define analysis for them. So now I can select NACA 0006. I can go to analysis, select define an analysis. The Reynolds number, we discussed that it shows that we are dealing with the laminar flow or the turbulent flow. If it's less than 500 K, so this would be laminar. If it's more, it would be turbulent flow. So now we want to fly in the lower speed. So I put it, let's say 400 K.
Okay.
And this is a Mach number that we discussed, is the ratio of the speed of your airplane divided by the speed of the sound. So for example, if we assume that the speed of our airplane is 20 meters per second, the speed of the sound in the earth is 346 meters per second. So if I divide them, I can get my Mach number. So this is something that we can put it here. You can use it, easily use calculator. Say 20 divided by 346 is 0.57, so I run it up as 0.06. Then we don't touch this. We actually don't work with the next type. I try to explain them in the lecture, but we don't actually work with this. Select OK. So for your case, since initially you are doing this, maybe you will see something like that. So if I apply sequence, so I can add a range of the angle of attack. So
right. What kept happening on mine is when I would click sequence, it would just give me the top and the bottom lines. It would not give me the in-between lines.
So do you want to share your screen and show it to me if you have it?
I deleted it because I figured I was doing it wrong. But I could pop one in really quick and do it.
Yeah, sure. If you can do it, I mean, I can help you and you can do this by yourself. And in this way, I can explain everything to you. So I'm going to give you as a co-host, so you will be able to share your screen with me, and I can explain on your screen the steps that you wanted to do. And then once to make sure that this is fine, we will go to the wing and I'll try to analyze all the wing stuff.
Okay, so let me see. Okay, so when I go here,
direct foil design.
right, if I'm going to put in the
You can go to the foil.
There we go.
Exactly. So you need to delete those zeros before 2416, okay.
Okay, and then the other one we did was 006.
Yeah.
Yeah, I am not super fast with computers.
That's fine. Neither do I.
Okay.
Sounds good.
Okay.
So, yeah, you need to change the color to make it visible.
Right.
Go to the style. Yeah. So you have both of them there, or you can increase the, yeah, any color that you want. And you have one more airfoil for NACA 006.
Okay, yeah, there we go. Yeah, it's so faint, I'm sure you can't even see it.
Yeah, I cannot see at all.
Okay, so I'm at where you were. Okay, and so then when we go to the analysis.
Go to the file.
Okay.
Export direct analysis, or you can press Control 5.
I'm not good with shortcuts.
So
Okay,
now
so
you
let's
have
start.
NACA 0006.
Okay, I want to start with this one, right?
Exactly. You can go to
Okay.
analysis first.
Oh, here. Sorry. Define an analysis.
Exactly.
Okay. And we wanted 4,000.
Yeah, 400,000.
400,000, sorry. And we were sticking with the 0.06
Yep.
for the mock.
Yep.
Okay, so that's okay. Yeah, I don't know why on yours this little thing was like docked to the side. On mine it just floats all around.
So are you using a Mac or Windows?
This is a HP.
HP. So it's you are using a Windows system, not
Yeah,
Mac
it's a
or
Windows system.
Linux. Okay, sounds good. So now press analysis.
Okay.
Oh, from -10 to 15. Okay, so analysis was done. Apply, close, that's fine. You can close it.
Close that.
Yep.
Yeah, and see, I only got 2 lines there.
So that makes sense, because here, can you apply the displacement thickness?
A displacement sequence? Thickness,
Yeah.
this?
Yes. So then press animate. So here, this shows you that how these graphs are changing.
Okay.
So
and
then you can see also, yeah, you see the angle of attack is increasing, and that red dashed line at the top, it shows the flow. So we will figure it out why it shows you two graphs here. So I mean, the main reason it can be that this has been analyzed in 2 angles, or yeah. So, oh, I found it. So one of them is for viscous flow. The another one is inviscid flow. Do you see here?
oh, okay. This?
So inviscid flow, it means that we are neglecting the viscosity effect.
So we don't want to do that.
So it doesn't matter. It's just a comparison, right?
Okay.
So that will be fine. There is no any problem there. And so now if you go to the OP point view at the top, do you see there is a beside NACA 2416, the word that you selected?
Oh, okay.
And you can see the pressure here, right? If you click on pressure.
Pressure?
Yeah, beside animate. So I want to show you
Oh.
this first and then go to
Okay,
Yeah.
pressure.
So it shows you pressure distribution, right?
Right.
So it shows you that how pressure is changing. So this is with the angle of attack, the center of your pressure, which is that resultant force or resultant pressure is changing. You see here that green vector that you have, one green vector, this one, you see, at the middle of the airfoil.
Oh, here.
Yep.
Oh,
exactly.
yeah.
So this is a resultant pressure, and the position is the center of pressure. So this actually is changing its angle of attack, the airfoil, right?
Right.
So now, can you go to that one, another graph, which is beside NACA 2416?
Okay, so choose the other one.
No, leave that one. Beside that, in the left side, you have another graph. Yeah, click on this.
Okay.
That's great. So now you can double click on your screen with the left mouse 2 times with the left side,
There. Is that what you want?
with the left.
I don't have a mouse. It's a laptop.
Oh, so it's with your laptop. So you need to left click. I don't know how you, like you are selecting something.
Is that it?
Yeah, exactly.
Okay.
So now you can select CL versus alpha. Click on OK. So you can zoom out a little bit.
Okay.
So do you see that? That's fine. Do you see that direct foil analysis? You can keep that window and push it to the right side of the software. Or double click. Yeah, double click on that.
Okay.
It automatically go. Yeah.
Yeah, I don't want to completely lose it. If I lose it, I don't know how to get it back.
So you can if you double click on that, it goes to the corner.
Oh, if we double click on it?
Mm-hmm.
No.
On the top. Yeah, here. So you are doing right click. You should do the left click in your laptop. Okay. Never mind.
Yeah. Left clicking on the laptop is like crazy. I try,
Yeah.
like it's one click over on the left side, and sometimes it works and sometimes it doesn't.
So
I'll move it to the side.
So do you see this graph?
Yes.
So this graph shows the lift coefficient versus the alpha, which is the angle of attack, right? So if you remember, we discussed that once you're increasing the alpha, so your lift is increasing to a specific angle linearly, right? It's like a line. But after, for example, angle of attack more than 5, you see that this is going to be curved, and it goes to 15, and after 15, it goes down.
Okay.
So at 15 or 14, at 15 here, you have your maximum CL, right? It should be about 1.3.
1.3. Okay.
Right. But also after that, the lift coefficient is start to decreasing. This is the place that angle of attack 15, your stall is happening, right? Okay. And there is an angle about minus 2.5. That it's the intersection between your lift line and your angle of attack. This is the alpha CL0, the one that your x-axis of your graph that is connecting with your graph is about minus 2.5, the horizontal axis. So you have 0, you have minus 5, you have minus 10. So at the middle of 0 and minus 5, you see here. Okay, here. Exactly. So this is the angle of attack that your lift is equal to 0. It means that your wing, it doesn't generate any lift.
Okay.
So now double click in that again, in that.
Is it left?
Yeah, 2 times. So now you can select CD. CD versus alpha. No CD in the left side and alpha on the right side. Yeah, exactly. So click on OK. So this shows you the RAG profile versus angle of attack. So if you remember, once we were discussing, if this is an airplane, if it goes with a 0 angle of attack, you have the minimum drag. You see that is a minimum, right?
Right.
But once your angle of attack is increasing, so it's moving like this, so you have more pressure drag because you have more surfaces that is touching. It's exactly once you are in the car, if you put your hand outside, if you put hand horizontal, you don't feel too much drag. But if you put like this, you will see it's forcing back, right?
Yeah, you'll rip your arm off.
Exactly. So this is a drag. So this is the reason once you're increasing your angle of attack from 0 or decreasing, so your drag coefficient is increasing, right? So this is something fundamental. I mean, there are too much equation behind this, but I don't want to make it too much complicated. But once you know the concept, you will understand everything, and would be more than enough.
Okay.
So can you right click again?
Right click?
Left click, sorry.
There we go.
And you can select CL over CD in the left side. Down, down, down. CL over CD, CL divided by CD.
Oh, okay.
Yeah. Click on OK. So as you can see here, there is an angle of attack where your CL over CD is a maximum.
At
Exactly.
here at like 82.
About 7 degrees, right?
Right.
So
this
is the angle that you can get the most efficiency of your system, because you always want to increase the lift, the forces that gives you lift, and your airplane can go up, and you want to reduce the drag because you are consuming less fuel or less, you need less power or battery. So this is the main reason that this graph is so important once you have a bunch of airfoil and we just want to select one so we can compare them, which one is giving us this more value of CL over CD. So there are some criteria in the airfoil selection that we have in that presentation. I think there are 12 criteria that we have ranked them in the previous lecture. We went over them. One of them was this CL over CD. So now let's do the same analysis for NACA 006. So you should go to that and select the airfoil. Go to analysis.
Oh.
Yeah, you need to share your screen again.
All right. I wonder why it kicked me out. That's weird. Hopefully it did not. Okay, that's weird. It looks like it closed somehow the program. Hang on.
I think it should be there. It closed the maybe the Zoom.
Now the Zoom is still open. It for some reason closed my
Oh, the XFLR5?
Yeah, the XFLR5. I've got to reopen
you can open it again.
That's weird. It didn't ask me if I wanted to save or anything. See, these are the difficulties that get us all. Are you still here? Okay. Okay, so I'm going to share screen.
Maybe that's good. So it's a nice practice. Sometimes I'm designing the whole airplane and this is happening, and then again I need to do everything again.
You have to do it all again. Yeah. We want direct foil design.
So is it open XFLR5?
Yeah. Oh, did it not?
So I see your folder.
Yeah, Zoom doesn't always play well with others. Now, do you have it?
Yep, I'll see that. So now we can add those two airfoils.
Okay, 2416.
Click on OK, and NACA 006.
Whoa.
Yeah,
that's not the right thing.
One more down. Next one.
Oh.
It is a NACA foil.
Yeah, it's just.
And 006. So here you don't need to change the color because I mean, this was just for visualization. So now you can go to the third part, file again.
Okay, go to the
File,
and
export
analysis.
direct analysis. Yep, exactly. So now you can click on the analysis. So first you need to define analysis. Exactly. So now we are doing for 006 first. Sounds good.
Okay, 400,000.
Mhm.
All right.
And this is fine. Click on analysis.
Yeah, on yours, this little thing that comes up on the left hand of my screen, it never came up when you were doing your demo, and I was just like, what have I done?
No, everything is correct. So
Okay.
now you can change the airfoil and run that analysis again. Do you want to
Okay.
go to first the OP point, the graph beside that in the left side?
Okay.
Yeah, we want to see that
Done.
graphs. Sounds good. So now you can go to analysis again and change the airfoil.
Oh, change it to the 2416.
Yep, exactly. You can go to analysis and define the analysis again first. No, there at the top, analysis. Yep, exactly. Sounds good. So now the same thing and click on analyze. So can you run it again? Oh, it went, that's fine. So can you click on this CLCD? Can you double click in your graph?
This?
Yep, select
And we want the
alpha.
CLCD ratio?
So you can select alpha.
Alpha?
Alpha versus CL versus alpha. So through this, you can get any graph that you want. So you see here what would happen. So NACA 006 has been installed earlier than NACA 2416. And you see that it gives you higher lift. Do you see?
Oh, yeah.
So this is something because, and you see NACA 006 was a symmetrical airfoil, right? And here at 0 angle of attack, it gives you 0 lift.
Right.
Right?
Okay.
Sounds good. So now go to the file.
Go to the file. Okay.
Go to the file. Go to Wing and Plane Design. Exactly. So now this is a 3D environment that I'm going to show you some example, and then we can practice with yours, right?
Okay.
So now I'm going to share my screen right now.
Okay, I'll stop. I'll let you share.
Sounds good. So I need to, analyze these two airfoil that I have here. So I'll do the same thing here as you did. Okay, CL alpha. Okay, so now I did the same analysis. I will go to the file. I'll go to Wing and Plane Design, right?
Okay.
So this is a 3D environment. You will see a blank page here. So in order to make an airplane, so you should go to the plane, right? You will go to the plane and you will press define a new plane. So I want to define a plane. So once I click this, these are the plane names. So for example, says Mustafa's or Susan plane. So, oops. And then here, any description that you want to write, you can explain it. So for example, this is going to be, this is an unmanned air vehicle. You can write anything that you want here. And then here, there are different components of the airplane that you can define them or design them. The first one is the main wing, is the wing of your airplane. So I'm going to show you this airplane too. You can easily model it here. So this is the wing, right?
Uh-huh.
So this is the main wing. Also, I have the biplane. It says the wing two. You remember we discussed two airplanes that they have two wings at the top of each other?
Yeah, the biplane.
So we can easily make those. Or tandem airplane, there is a wing after each other, you know?
Oh, but the parallel.
Yeah, they are parallel. So you can also make those. Elevator, here it means that you have horizontal tail, which is going to be this.
Right.
Right? Fin here means vertical tail. So these are the fins. Right? And there is a body, which is this body.
Okay.
So now I want to show you first.
So does the blue plane you have, would we say that it has no body since it's basically just a big wing?
So once you have a flying wing, you just have one wing. You no longer have body.
Okay.
Like this. But I have a small body here, but there are lots of like B2, if you like the airplane B2,
Yeah.
or RQ-170, they're just a flying wing. They don't have any body. Body is integrated to the wing.
Okay.
So to make this one easy, first, before going to design, I want to show you how you can, what you can get from the default of this software. So the first one is a wing. So I want to define my wing, and X and Z is the position and angle of my wing. So I will go to the define. And here, these are the different views. So this is an isometric view of the wing. This is going to be front view. This is going to be side view. And this is a top view, right? Top view of my wing. So do you see this? This is a 0, 18, 0.
Yes.
So this is my Y. Do you see this is Y?
Yes.
So, and this is my Y. So the Y at 0, this length is 18.
Oh, okay, the chord.
So if I change it to 30, so it becomes bigger, right?
Okay.
So the second one is the end of my wing, correct?
Right.
So this is a half of, do you see here it shows symmetric, and this is the right side, right? So here, 100 centimeter, it means from here is my coordinate, this is my X, this is Y. From here, this axis to here is 100 centimeter.
Oh,
so
okay.
It's half of my wing. So if my half of my wing is 100 centimeter, so here you see wingspan, it should be 2 times than that, right? It's 200.
Yeah, it should be 200.
Exactly. So, and this 11 is here, is this length.
Okay.
And this offset is from this horizontal line to here. If I put it 0, it becomes like this. If I put it 10, it becomes like this. If I put it 60, it becomes like this. So it's distance from here to this horizontal line, right?
Okay.
Sounds good. So now let's say that you want to add more section to here, to your wing. I can go to here Y, for example, in section 1. There is a part here, insert before section 1 or insert after section 1. Since I start from 0, I can say insert after section 1. So I added another section here, right? So this is 50. So let's say I'll change it to 30, right? And here the core length is 20. I'll make it again 30. And this offset is 30. Let's say make it 40. Or I make it 20. Right? So you can make any geometrical shape that you want through this. So for example, the core length is 30, I'll make it 60. Right? I made a wing.
Yeah, looks like
so any geometry that you have. So let's say that consider that here I have 3 cross section, right?
Right.
This is 1, second, and the third. So the first one, I have its length and offset is 0 because I want to start, this is my reference line. The second one, this is 30. It did at the distance of 30 with the chord length of 30. and with the offset of 20 from here to here is 20. And I can, let's say, open a paint and explain it here. So, okay, I need to see this number. So for example, if I draw a line here, so the first one, I have 0, which is, this is 0, and this is going to be 60. This is 60 here. This length is 30. This length is 11. From here to here is 0. The second one is 30. So from here to here is 30. From here is 100. From here to here is 100. Right?
Okay.
And the offset here is 0. The offset here is 20. The offset from here to here is 60. Right?
Okay.
So this is any geometry, any shape of the wing. If you have the curved shape, you can easily add more. Like, you know, a circle is a composition of infinite sides, right?
Mm-hmm.
Here is the same. If you want to have a curved shape, I can add more section to make it more curved. So if you have an elliptical shape or a circular shape, you can easily make it here.
Okay.
Right. So this is my wing, top view. And there, I have a dihedral angle. Do you remember we were talking about dihedral angle is like this? We said that, right? For stability, lateral stability we discussed.
Yes.
So if so this is a side view. This is side view, front view, and the top view, right? So if I change the dihedral angle here, all of them to 10 degrees. So let's see what we will get. So now if I rotate this, do you see there is an angle here?
Yeah. Yeah. So now it's, yeah.
So this is my dihedral angle. So before I to see this, so I make it 0, I want to add airfoils here. So this here is a foil. So now there is I have not added any airfoil. So now I want to add any airfoil that you added there, you can see them here. So for example, I had NACA 006 and NACA 2412. So I can select NACA 2412 here, NACA 2412 here, and NACA 2412 here. So the airfoil has been added here. So now if I go to the side view, you will see this airfoil. So if I show the foil name, do you see this shape of your airfoil at the middle of your wing? In the side view, so this was our airfoil, right?
Right, our nice shape.
Exactly. So you have this airfoil shape here, here, integrated everywhere. If you want to select the airfoil of one part of your airplane different, I can, for example, say that this is NACA 006.
Oh, wow.
So I can have an airfoil, which here is NACA 006, here is NACA 2412. What is the airfoil between these two? Do you remember we had interpolation between two airfoil that it was changing? So this is interpolating between these two, and maybe the infinite airfoil between this. So, but I make it all same. So now if I go back to this view in the dihedral angle, so now it should be more visible. So if I change it to 10, so do you see that this is my dihedral?
Oh, yeah.
If I put it -10, so you have anhedral angle, right?
Yeah.
So if I put this one 0, 0, and this one 20, this one 20, so you will get this was, we had a situation where a part is constant, the rest has a anhedral angle, right?
Right.
It's called polyhedral angle, I think, if I be right. So you can add this angle if you want, but I make it 0 for now. So then there is a twist angle. So let's, so this is an isometric view here. This is an isometric view, it shows this. The twist angle means that you are twisting your wing. This is usually not happening, I mean, commonly in the airplane, but here, just to show you, if I put 30 degree here and 60 degree here, so you see that the wing has been,
oh, yeah.
so it's just twisting the airfoil. But I'll just consider 0 for everything. So, and so in order to run the analysis here, I mean, we'll explain this a little bit more once we run the analysis. So if I go to the top view of my wing, so here, this is the axis. You see here is adding axis, XYZ. This is the surface, if you want to see the color or the surface. This is the airfoil name. You see NACA 2412 is written everywhere. This is a panel. So this panel is important because for the aerodynamic analysis is the CFD modeling, which is this is using computational fluid dynamic, is making a wing as small panels and run the analysis in one by one of this panel and do the integration. But here, usually it's better to apply a reset mesh. So once you apply a reset mesh, the software, it select the best panels for your analysis.
Oh,
right?
Oh, okay. The best size.
So here, let's look at the component. Wing span 200 centimeter, you have the wing area, you have the projected span. So you see the projected span is 200 centimeter here, right?
Right.
So if I add a wing loading of the dihedral angle about 20 degree, so you see that it become less. Because if I see this view, so this is going to be from here to here, right? So it's a cosine of this angle. So cosine of 20 degree. So this is the reason that projected span is going to be smaller because it's from here to here. If I do a print screen again here, just show you. So the projected span is from here to here. But the actual span is from here plus here to here, right?
So it's still 200, the actual.
So actually it's more, right? Because if the cosine of this angle, cosine is always less than 1. So it is less. So this is the reason that projected span is less than your wing span.
Okay.
So you have the same for surface area. You have projected surface, and you have mean aerodynamic chord. This is something that is the average of this chord, right?
Right.
And you have the root to tip sweep angle. Do you remember we talked about sweep angle?
Yeah.
We were saying that a quarter of this, for example, this is a quarter of this. If it be connected to quarter of this, the angle that this is making with the horizontal line is called sweep angle. And here it shows you the number of the panel that you have here, right? The summation, all of those.
Wow.
It's about 946 panels.
Wow.
So then if I press save, the wing is saved, right?
Okay.
So now we want to make a body. So I can go to the body, click here, and I can press action, edit, right?
Right.
So this is a default body of your airplane here. So do you see this point here? So this is my axis, right? My X axis. This is my X axis, and this is going to be my most probably a Y axis. So this is X and Y. You will see it here, right?
Mm-hmm.
So these are my X. Minus 24.3 is the distance from here to this axis. Minus 22, minus 5, and this is 0, right? These are the position that I have. So for each of this section of these points, I have a cross section here. So for example, let's go for this point, minus 5.1. I have its corresponding Y and Z. So these are the points that they are making the cross section of my plane here, of my body here. So if I change them, you will see that it become bigger. You see here?
Oh, okay.
So if I make it more correct, So, but you can, if you have a design, so you can, you will be able to change them here. So for example, the y of this is y, this length is y, I put it 0. And then I have this one, let's say I put it 5. This one, I put it 5. This one, I put it 0. And this one, I also put it 5. So here, the distance from here to here, I put it again 5. Here, I put it 5. I put this one 0. I put this one -5. And I put this one -5. I made a simple shape, right? So you can adjust them. So you see here, it says the degree. So if I put degree 1, it shows, and the hoop equal to 1, it shows you exactly as this position. It's not rounding up. There is no any fillet for the edge, right?
Oh, okay.
Right. So this is a simple rectangle that I draw it here, right?
Right.
So now if I change the degree to, let's say 3 here, and the hoop to 3, you see that's curved more.
Oh, okay.
So now if I put the degree 5 and hoop 5, so you see that, okay. So now it's all curved. This is become more circular shape. So this shows the degree of this. So if I put 2, so it become like this. If I put 1, become like this. So this is something that you can easily do. You can adjust it or what shape you want to select. So this is it for each point. You can do this. So for example, this is 9.4. So if you want to make them, so for example, I put this on -25, -20. I just rounded them, 10, let's say 30, 70, and 70. So I make the last 2 the same because I want to close it. I don't want to have any open area here. And this is -25, so it's just one single point. I can make everything 0, right? So you can make everything 0. Then at -25, you can put any dimension that you want. You see here, so you can put any dimension that you want. So for example, if I make this one as a 5, to make it a little bit more better fuselage, 5, 5, 0, -5, -5. So now I have enough space here for my body. For this section, same. If you want to add more section, so for example, you can also change it manually. You see here, you can take the points and change them manually, and also you can play with them with just inserting the exact value of point. If you want to add more points, so for example, I can right click here, it says insert control point. Right, I just right click here and select insert control point. So I have another point here, so I can change it manually, or I can again go to here and adjust them. Correct?
Correct.
So this is the body. So again, this shows the degree. This is a flat panel. If you see the flat panel, you will see, you don't see this degree. It's exactly what you have here, right? It will be just these points. It's connecting linearly. But if you see BS spline, so it will be curved better. So now let's say that this is the body of my airplane. If I click color, I can select any color that I want for the body of my airplane. If you select texture, it shows you like airplane, the cabin and everything, right?
Okay.
The same for wing. You can select color or you can select texture. So let's select texture here and click on the save. So now you made the body. If you want to change, same in the color here in the wing, you can change the color or you can select texture. So let's select texture. So then let's make the tail. So this is the horizontal tail, elevator, right? So if I define, this is exactly similar to what we had for the wing, but this is going for the tail. So I'm going to remove the panel here. So we'll see just the wing. So this is a horizontal tail. So this is a front view, side view, and top view. So again, usually we just have two sections. If you look at the tails, you just is a simple rectangular shape or tapered wing, right? So you have just two sections. So I'll keep it as it is value here, a little bit maybe bigger, 20. I can make this one, let's say 15, make this one 10, and make this one 10. So for example, this is my horizontal tail. Or if you want to make it simple, I can make it like this, 5. So then the same dihedral twist, exactly like the wing, I will add NACA 006 airfoil here. It's exactly like the wing. It's nothing, it's the same way that you're making the wing. Then you can apply panels. I can press reset mesh, so it will appropriate sizing of mesh will be justified here. Okay. Do you have any question here, Susan?
I was just going to see at this point, can you, like we did with the main wing, can you have a third section, or is it just the two?
So you can have the second wing as well, but I want to make a conventional airplane first for you, and then some unconventional shapes, like 2 wings parallel, I mean different shapes of the tails. But this is just a simple horizontal tail. It's exactly like the wing that we did. So now you have the characteristic. You have the wingspan or tail span. You have their area. You have its aspect ratio, which is the wingspan square divided by wing area. So you have the geometrical characteristics here. Then I'll press save. So then I'll go to the fin. I want to make, so you can also make this texture. I make the fin and then I'll save it. You will see that the whole geometry combined, and I'll change some values to see how we can adjust it. So for the tail, I'll select the fin, define. So this is just a vertical tail. So here is exactly like this. I want to make something like this. So I will get rid of panels here. This is, I need to see the view of the tail. So I'll keep the same direction. So this is 0, right? This is 12. The distance from here to here is exactly like tail. The chord length here is 10. Here is 6. The offset for the first one is 0 from the y-axis. For here is 4, right? This is 4. From here to my y-axis. Then I can add symmetric airfoil. Make sure that all the time that airfoil that you're selecting for your vertical tail should be symmetric, because airplane should be symmetric, right?
Right. Yeah, you want it to be.
So again, I can select panels, reset mesh. So this will be reset, justified, and I can select texture. Then I can click on the save. So now my airplane is ready. Everything is ready. Everything, it has a default position that we can change it, and I will show you later. So you will see that here is some information. What is your wing area? What is your wingspan? Your elevator, which is your horizontal tail area, horizontal tail arm, fin area, which is your vertical tail, tail volume, and total panels. So this is something that software is calculating based on all this data that we inserted. So now if I press save, and if I press here surface, it shows your airplane.
There we go.
Right? This is your airplane. It's
That's
so
cool.
easy. So now let's say that you want to push this tail back.
Right.
Or you want to push your wing in the front. So you can right click here, right click, current plane, edit. Right? Again. Right click, current plane. If you want to just edit the wing, you can select edit the wing, edit the elevator, edit fins, to have all edit. But if you want to edit their position or all of them in the same time, you can go to edit. You will get back to this windows. Right? You have this. And so for example, this wing is at x0. I want to make it backward or forward. So here, so for example, if I put it -20, right?
Okay.
If I click save, see, it become front. So now your body is, right? Or if you want to make it backward, so I can say +20. It goes back, right? So you're positioning your.
Okay, and if we like that, but we need now to move the tail back, we just need to move
Exactly.
the tail, right?
If you
Okay,
like that,
so let's keep that and let's move the tail back.
So for example, tail is 60. I need to make this one 80, and the same for the fin, for the
Right, we need.
right, 85, because I added 20. So now it goes there. Right.
There
So
we
now
go.
my body it doesn't reach to here. So I need to revise my body. So I can right click here, current plane, edit. I can go to action, edit, right, for the body.
Right.
So now I can take this one and this one here. Right. So I push it backward as long as I want. So now save. Save. Do you see here? So now I can push them more back.
Right.
So now I don't know how much I added, but this is going to be, let's say, 130. Hopefully I'm correct. 135. Okay. 120. 125. There you go. Almost close.
Pretty close.
So you can make your airplane like this. So you have this option, 115, oops, 120. So now let's say that this is your airplane that you have made, and you want to have an angle of attack for your wing. So I want to angle my wing, the installation angle. So this is a tilt angle here. So I can put this as 0. I can put it, let's say, so usually it's between 0 to 5 degree, but to just show you that make it visible, I'll make it, let's say, 15 degree. So do you see that how it has been angled?
Yeah.
So now I can go to the edit. I can make it, let's say, 2 degree.
Oh, that's better.
So 2 degree. So sometimes you want to make your wing upper. So you can, this is the Z here. So this is 0. If I make it 20, so the wing is become up. So if you want to go back, so I put that Z0. So you want to have a T-shaped tail. You want to make this one at the top. So if I go to my here, this is 12, right? The distance from here to is 12. So now if I make the Z 12, if I press save, oh no, sorry, I did. This should be 0. Here, your horizontal tail should go at the top of this. So if I put this T12, so my horizontal tail goes at the top of this.
Okay.
Right, so now it's a T shape. I need to move this one a little bit forward, 100, 105. So something like this. So now this, you have a T-shaped tail, right?